Designed as an all-in-one virtual reality system, the Oculus Quest 2 is an amazing advancement in the technology involved with virtual reality entertainment. And of course, the programming behind this system would be incomplete without the proper hardware to back up the experience. The system has an Android-based mobile chipset installed, making it very viable for the lightweight use it has. In each eye, there's an 1832 by 1920 display resolution, giving users a very detailed experience into the virtual world. The system has 6 gigabytes of RAM, giving it ample space without being too heavy. It has a 72 hertz refresh rate, a fast switch LCD panel, and an inside-out 6DOF movement tracking system in place. All of this hardware combined makes the Oculus Quest 2 very powerful and very advanced. And of course, none of this technology would work without the proper coding and programming put under the hood to make it run beautifully.
Unity is the most widely used 3D development platform in the world. It powers 40% of the top 1,000 mobile games on the marketplace. Basic concepts of the Unity engine are the scene, game objects, components, and materials. When developing, the player has a virtual body with head movement and also right and left hand movement being tracked by the virtual world space. Oculus integration for Unity provides plugins and scripts for controller and headset input. C# is the typical language used for scripting the different game objects and materials and scenes inside of the games. And now Junji will talk to you about its rival competitor, Unreal, and more about that.
One important element in making a game is the logic. When the player presses the button, the character should interact with the input. In the VR game, when the players move their body, the coordinates should change, and the blueprint system from Unreal Engines will make game logic more visible, so game maker can have a clear vision of seeing the logic in the different scenes of the game. That because a game engine like Unreal is a framework which supplies many functions to game makers. It's like a wheel, you can simply use it without understanding how it works. However, problems sometimes occur, so you need to track the problem down to the last bit of the code. The sweet point is that Unreal Engine is able to modify the hard content of the code once you become the subscriber.
The goal of the Oculus and any other virtual reality system is to make the user immersed in a virtual world. As such, the world needs to have realistic audio. This means that we're striving for spatial audio instead of the traditional surround audio systems found in most media. Spatial audio, as opposed to surround audio, attempts to emulate how sound propagates through a 3D space. Currently, the Oculus supports the Oculus Spatializer for developers, which allows for the emulation of 3D direct sounds. However, this neglects reverb altogether. Reverb, in fact, is more of what you hear in an actual natural sound setting than direct audio. So developers currently get around this by having a constant reverb set in their environment. However, the real world has differing amounts of reverbs dependent on your location, so this takes away from user immersions. Currently, Facebook Reality Labs and other researchers are attempting to create an audio ray tracing engine in an attempt to get natural sounding reverb. So next you'll hear from Eric on the Oculus's equipment coordination.
The Oculus Quest uses constellation tracked controllers to track the movement of both the headset and the controllers in their hands. The concept of photogrammetry uses the images taken by the cameras on the headset to track and measure distances. It was adopted by Oculus to help track the movement. However, problems have arisen from this. For instance, the position of the headset controller is known with high confidence. However, it's somewhat difficult to find where the hand controllers are. However, there are LEDs on the controllers, which the camera uses to use and locates the LEDs, matches them, and uses some probability algorithms to figure out which LEDs are which. Incorrect matchings can lead to errors that later on can cause problems. And so it's vital to really try and minimize LED matchings or matching errors. However, with updates to the Quest, we have actually gotten rid of the controllers altogether. And it actually uses something called machine vision, which is a form of artificial intelligence to determine what a hand is and what a hand isn't. And so it will use the photographs from the camera on the headset to figure out what the hands are and figure out where they're going.